Hey guys, welcome back to Math with Marilyn. Before we get started, make sure to grab a pencil and paper so that you can take notes as you follow along. So today's topic is using the converse of the Pythagorean theorem. The goal is for you to determine if a triangle is a right triangle by using the converse of the Pythagorean theorem. The converse of the Pythagorean theorem states that if the sides of a triangle have lengths A, B, and C units, such that A squared plus B squared equals C squared, then the triangle is a right triangle. If you reverse the if and then statements of the Pythagorean theorem, you have formed its converse. Statement. If a triangle is a right triangle, then A squared plus B squared equals C squared. So the converse of that is if A squared plus B squared equals C squared, then the triangle is a right triangle. The converse of the Pythagorean theorem is also true. So let's take all of that information and make sense of it all. So let's try one together. So in our example, it says, consider the triangle with the dimensions 3 meters, 4 meters, and 5 meters, as you see here in the image. To determine if the triangle is a right triangle, use the converse of the Pythagorean theorem. So basically what that means in simple terms is you're going to label your triangle with A, B, and C. Remembering that C is always going to be your longest side. You're going to simplify the left side and then see if it equals the right side. If they equal, then you have a right triangle, and if they don't equal, then it's not considered a right triangle, or then it's not a right triangle. I'm getting tongue-tied with all this triangle Pythagorean theorem, so excuse me. All right, so I know that C has to be my side that's labeled 5 meters because C has to be my largest side if this is going to be a true statement. So I'm going to label the other two sides A and B. Again, remember that you're using the Pythagorean theorem, which says A squared plus B squared must equal C squared. Well, in this case, because we're trying to decide if it's a right triangle, once I substitute, I'm going to use a question mark over my equal sign, and I'll show you what that looks like. So my substitution goes, A is 3, so I have 3 squared. B is 4, so I have 4 squared. And we are testing that out to see if it's going to equal C squared, which will be replaced with 5. Again, make sure you pay attention to the fact that I put my question mark over my equal sign because I don't necessarily know if the left side is going to equal the right side yet. So that's where my question mark comes in. All right, so now that I've done my substitution, I'm going to evaluate my exponents. So I have 3 squared is 9. Remember that means 3 times 3. Bring down my plus sign, and 4 squared is 16. Remembering that means 4 times 4. Again, I'm putting my question mark over my equal sign because I still don't know if they equal yet. And 5 squared is going to be 25. Remembering that 5 squared means 5 times 5. The next step is to add 9 plus 16, and that gives me 25. Well, does 25 equal 25? Yes, 25 will always equal itself. So that means that this satisfies the converse of Pythagorean theorem, and that this is yes. It is a right triangle. Simple. So, quick recap. They're going to give you a triangle with 3 lengths. you need to make sure that you label the longest side as your C. The two sides we labeled as A and B. So then I substitute that information into my Pythagorean theorem formula, placing my question mark over my equal sign because I don't know yet if my left side is going to equal the right side. That's what I'm trying to determine. All right, once you do your substitution, then you're going to evaluate your exponents. So 3 squared was 9, 4 squared was 16, and 5 squared is 25. Again, when you rewrite, make sure you include that question mark because we don't quite know if the left side will equal the right yet. Last step here is to add 9 plus 16, and that equals 25, which makes a true statement that 25 does equal 25, which confirms that the converse of Pythagorean theorem is true and that this is indeed a right triangle. Hopefully this quick recap on using the converse of the Pythagorean theorem was helpful. If you have any questions or comments, leave them below the video and make sure to share and subscribe to my channel, Math with Marilyn. Thank you and tune in next time.